Welcome students. In this video, I am going to discuss some questions from exercise 7.2. Question number 1. In an isosceles triangle ABC, side AB is equal to side AC. The bisector of angle B and angle C intersect each other at O. Join A to O and then show that OB is equal to OC, and the second part is AO bisect angle A. Just look here. This is triangle ABC and it is given side AB is equal to side AC. Next is the bisector of angle B. This BO is the bisector of angle B. It means these two angles are equal because BO is bisecting this angle B, right? And the bisector of angle C. The CO line will be the bisector of angle C. So that means these two angles are also equal. They intersect each other at O. The next thing is join A to O. Then in first part you need to prove OB is equal to OC and AO is bisecting angle A. That means you need to prove these two angles are also equal. Now look at the solution part. In triangle ABC, we are given side AB is equal to side AC. And we had done in theorem 7.2 that the angles opposite to equal sides are also equal. So angle opposite to side AB is C and angle opposite to side AC is B. So that means if AB is equal to AC, angle C is also equal to angle B. Or we can also write angle B is equal to angle C. Right reason here. The next thing, divide by 2 on both sides. So half of angle B is equal to half of angle C. Now this BO line is bisecting angle B. That means these two angles are equal. Or we can also write the angle half of angle B is equal to angle OBC, because this angle is divided into two equal parts by this line BO. So that means these two are equal, or we can write the half of angle B is either equal to OBC, or we can also write OBA. So I am writing half of angle B is equal to OBC. Similarly, half of angle C is equal to angle OCB. This is your angle OCB. Done? Next thing. Now, look into the triangle OBC. You have shown that these two angles are equal. This is your angle OBC and this angle is OCB. And we know that the sides opposite to equal angles are also equal by theorem 7.3. So that means if these two angles are equal, the sides which are opposite to these two angles will also be equal. So OC is also equal to OB. So this is the first part which you need to show. So we have shown that this side OB is equal to OC. The next thing, you need to prove that AO is bisecting angle A. That means you just need to show these two angles are also equal. Right? Now, in triangle ABO and in triangle ACO, we are going to show that these two triangles are congruent. I am again repeating. We are going to prove that triangle ABO and angle ACO are also congruent. Just look here. In this triangle OABO and in ACO, the first thing is side AB is equal to side AC because this is given in the theorem. Next thing, side OB is also equal to side OC. This you have proved in the first part. And this line OA is common to both. So I have written AB is equal to AC. This is given. OB is equal to OC. Proved in the first part. AO is equal to AO common. So that means by using side SSS congruence, these two triangles are congruent. Now if these two triangles are congruent, by using CPCT, this angle is also equal to this angle, or we have shown that this AO line is bisecting angle A. So I have written here these two triangles are congruent. Then we'll write angle BAO is equal to angle CAO. That means this angle BAO is equal to angle CAO, or you have proved that this AO line is bisecting angle A. Question number 2. In triangle ABC, AD is the perpendicular bisector of BC. See figure. The diagram is given in your NCERT book. In triangle ABC, this is your triangle ABC. AD is the perpendicular bisector of BC. Then show that triangle ABC is isosceles triangle in which AB is equal to AC. Now this diagram ABC, this triangle ABC in which AD is the perpendicular bisector of BC. Now it implies side BD is equal to side DC. You need to prove side AB is equal to side AC, right? So in triangle ABD and in triangle ACD, look here. The first part, AD is the perpendicular bisector. That means these two angles are equal to 90 degrees. So I have written angle ADB. This angle is equal to angle ADC. Both are equal to 90 degree because AD line is perpendicular to BC. That means these two angles are equal to 90 degree. So I have written angle ADB is equal to angle ADC. Or you can also write here angle 1, angle 2. They are equal to 90 degree each. The next thing is BD is equal to DC. Or you can write BD is equal to CD because this AD line bisect BC. It is given in your statement. Next, AD is common. So that means this side is common. These two angles are equal and these sides are also equal. So by using side, angle, side. I am again repeating. This side is common. These two angles are 90 degree. These two sides are also given to be equal. So by using side, angle, side. So by using SAS congruency, these two triangles are congruent, right? Now if these two triangles are congruent, by using CPCT, side AB is equal to AC, right? So if in triangle ABC, side AB is equal to side AC, that means two sides are equal. So this triangle is going to be isosceles triangle. The third question, triangle ABC is an isosceles triangle in which the altitude BE and CF are drawn to equal sides AC and AB respectively. Now read the statement carefully. It is given that triangle ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB respectively. See diagram. The diagram is given in your NCERT book. So we are given that ABC is an isosceles triangle in which side AB is equal to side AC. Further, BE is the altitude to the side AC. That means this BE line is perpendicular to side AC, and CF is also altitude to side AB. You need to show that these two altitudes are also equal. I am again repeating the statement. ABC is an isosceles triangle in which side AB is given to be equal to side AC. BE is altitude to side AC and CF is altitude to side AB. You need to prove that these two altitudes, that means, are equal. That means we need to show BE is equal to CF. Look into the solution part. In triangle ABC, AB is equal to AC. This is given. So angle C is also equal to angle B. This is your angle C and this is your angle B. Because we know that angles opposite to equal sides are also equal. Right? Now, in right triangles BFC and in CEB, look into the diagram. I have taken these two triangles B, because you need to prove BE is equal to CF. So I have taken the right triangle BEC and another label with red color, one with blue and another with red. In right triangle BEC and in BCF, angle 1 is equal to angle 2 because both are of 90 degree, right? Side BC is common to both. And angle in this triangle, in red triangle, angle B is equal to angle C here in the blue triangle, right? So I am again repeating. Now in right triangles BFC, this is going to be your BFC, the one which is labeled with red color, and in right triangle BEC, or you can also say CEB, the triangle which is labeled with blue color. Look here, angle 1 is equal to angle 2, each is of the 90 degree, and the first triangle is BFC. Here the angle B, right, this angle B is equal to, in triangle CEB, angle C, right? This is proved above, and the side BC is common to both. So that means these two triangles are congruent by using, just look here, angle, then angle and side. I am again repeating, angles, these two angles are equal, these two angles are equal, and this side. So by using angle, this is angle, and then side, angle, side congruency. So by using AAS congruency, these two triangles are congruent. Now if these two triangles are congruent, so we know that the corresponding part of congruent triangles are also equal. So that means if BFC is congruent to CEB, so this side BE is also equal to CF by using CPCT. Next question, question number 4. ABC is a triangle in which altitudes BE and CF to the side AC and AB are equal. The C figure, again the diagram in this question is also given in your NCERT book. Show that triangle ABE is congruent with triangle ACF. The second part, AB is equal to AC. That means we need to prove ABC is an isosceles triangle. So read the statement carefully. ABC is a triangle in which BE is the altitude to the side AC and CF is an altitude to the side AB. First you need to prove triangle ABE. ABE, the one which is labeled with blue color. I am again repeating, ABE is congruent with the triangle ACF, the triangle with the brown color. You need to prove these two triangles are congruent. Now look here, in triangle ABE and in triangle ABE and in triangle ACF, the first thing we are given in the question that the altitude BE and CF are equal. In this question, you are given that these two altitude are equal and you need to prove the sides are equal, right? So, in triangle, first we need to prove these two triangles are congruent. So, in triangle ABE and in triangle ACF, BE, this altitude BE is equal to CF. It is given in the question. The second thing, this angle is going to be common in both the triangle. I am again repeating, first thing, the altitude are given to be equal. Now this angle A is common in both the triangle, but I am writing like this. The first triangle is ABE. So for this triangle, I have given the name of this angle as BAE, right? I am again repeating, this angle is common to both the triangle. So I have written angle BAE is equal to, again for the second triangle AFE, this angle is equal to angle CAF, or you can also give the name angle 3 here, right? So you can write angle 3 equal to angle 3 common, but I have written angle BAE is equal to angle CAF common to both. And again these are altitudes, so that means angle 2 equal to angle 1. Both are of 90 degree. So these two triangles are congruent by using this angle and then angle. This angle is common, and then side, this side. I am again repeating, if you look into the brown triangle or in the blue triangle, this angle right? This angle in brown, and then this angle and the side, this side, CF. Right? So by using angle side congruency, these two triangles are congruent. If these two triangles are congruent, by using CPCT, AC side must be equal to AB. Right? So we have shown that in triangle ABC, side AB is equal to AC. So this is going to be an isosceles triangle. I'm again repeating the first part. You need to prove triangle ABE is congruent with the triangle ACF. Now in triangle ABE, if you look into the triangle ABE, the altitude BE, this is given to be equal to, in triangle AFC, this is equal to the altitude CF, right? These two are given to be equal in your question, right? Further, this angle is common. So I have written angle BAE is equal to angle CAF because this angle is common in both the triangle. The next thing is angle 1 and angle 2, they are of 90 degrees. So that means by using angle, if you look into this triangle, angle, angle and then side, right? So angle, angle, angle and this side. This side you need to prove are equal. So by using angle, angle and then side. So by using AAS congruency, these two triangles are congruent. Now if these two triangles are congruent, so that means this AC is also equal to AB.